Good morning, students. Welcome back to science class on the chapter motion. Today we will discuss some problems. Okay. So here first one. So here first I will put the question here and solve it and put your answers in the comment box. Okay. First one. A train starting from rest attains a velocity of 72 km per hour in 5 minutes. Okay, a train starting from rest. Okay, starting from rest. What it indicates? So initially that train, it is at rest. Okay. So if it is at rest, then clearly we can say that initial velocity is equal to 0. Okay. So we can write initial velocity is equal to 0. Next, attains a velocity. It attains a velocity means it gains a velocity. So what is that? So that is final velocity. Here that object, it comes from rest to 72 km per hour. So we can say that 72 km per hour is the final velocity. Okay, so V is equals to 72 kilometer per hour. Okay, next in 5 minutes. Okay, so initially it is at rest. Its velocity changed from 0 to 72 kilometer per hour in 5 minutes. Okay, so 5 minutes, what that is? Time. T equal to 5 minutes. Okay, next. Assuming that the acceleration is uniform. So here we should assume that acceleration is uniform. So find first question the acceleration. Find the acceleration, first question, and second one the distance traveled by the train for attaining this velocity. Okay. So first here our work is to calculate acceleration. Okay. See, we have three formulas. So first one is V equal to U plus AT. Second one, S is equals to UT plus half AT square. And third one, V square is equals to U square plus 2AS. Okay. See here, acceleration here is there, here is there, here is there. You can use any formula to calculate acceleration. Suppose, just imagine you are using this one, V equal to U plus AT. Here, if you use this formula, then you should know the values of VUT. Okay. Suppose if you use this one, here you should know the values of UT. That's it. Okay. Suppose if you want to use this one, then you should know V value, U value, and S value. Okay. See here. Now, just I will take this one. Okay. If you use this one, here we know final velocity, initial velocity, but we don't know displacement, right? So we can't use this one. Okay. Next, third one, S equal to UT plus half AT square. Here we know U value, T value, but we don't know S right here also, so we can't use that. Now go with first one. Here see, we know V value, U value, and T value, so definitely we can calculate A. Okay. So first I will write the formula. V is equals to U plus AT. See, keep in your mind while solving problems, first you have to write the formula. Okay. While solving the problems, first you have to write the formula. See here, what is the first one now? See here, V is in kilometer per hour, right? So better convert into meter per second. In the beginning classes, I have told, right, how to convert from kilometer per hour to meter per second, or meter per second to kilometer per hour. Okay? Yes, sir. So now how to convert this one? First convert, now tell me, convert into meter per second. So put your answer in your comment box. Yes, I am waiting for your answer. So now convert into meter per second. Fast. Yes, it is. Yes. Okay. First, no one is answering. Quick, quick. Yes, Sonia Gowda. Yes, it is a. Okay. See, if you want to convert kilometer per hour to meter per second, here first you have to multiply 5 by 18. Okay. So I will do here 72 into 5 by 18. So tell me the answer. 72 into 5 by 18. 72 into 5 by 18. Fast. Tell me the answer. Yes, Sangeeta could answer 20. Yes, correct. What is that? 20 meter per second. Okay. So when you multiply 72 into 518, you will get the answer 20 meter per second. Okay. Yes. So now final velocity is 20 meter per second. So now time is t equal to 5 minutes, right? So now convert. Now tell me in seconds. So convert that t equal to 5 minutes. Tell me seconds. That is 300 seconds. Okay. So now substitute. So we need a, right? So first bring t this side. First I will bring u, that is v minus u equal to 80. Then I will bring t. So now here it is in the form of multiplication. What happens when you bring this side? So v minus u then divided by t equal to a. Okay. I will use this one, or we can write a is equals to v minus u divided by t. You can, or you can use a direct, acceleration formula, a equal to v minus u divided by t. Okay. Yes. So now here substitute the values and tell me the answer first. Substitute the values. Yes, so many students answered. Yes, so 2020. Mention the SI unit. Don't write only 20. 20 meter per second. Okay. Yes. So now here substitute the values and tell me the acceleration. Fast. Yes, the answer is Sangeeta answered. The answer is 1 by 15. Yes, correct. What is the SI unit? 1 by 15. It is meter per second square. Okay. Now see here. V value is 20. Oh, sorry, V is 20 and minus 0 divided by T is 300. 300. What is the answer? So 20 minus 0, that is 20 divided by 300. Okay, 0 0 cancel, 2 2 50, that is 1 by 15. 1 by 15 meter per second square. 1 by 15 meter per second square. Okay, so I will write here. I will use this one. So here, right? A is equals to see 20 minus 0, that is 20 divided by 300. 0 the cancel, 2 ones are 2 15s are, that is 1 by 15 meter per second square. So this is the acceleration. Okay. So you see, initially that object it was at rest. Its velocity changed to 0 to 72 meter. Okay. So in 5 minutes, and its acceleration is 1 divided by 1 by 15 meter per second square. Okay. Yes. So now next move to second one. What is that? The distance traveled by the train for attaining this velocity. Now we should calculate distance. In a straight line, both the distance and displacement are equal. Okay. Yes. Now how to calculate? Just check here where distance is present. So distance is there, right, in equation 2 and 3. Okay. So now we got acceleration, that is a equal to 1 by 15 meter per second square. Okay. So now I will use this one. Let's see. We need S, right? So we know U value, T value, and A value. So we can go with this one, right? Yes, definitely we can use this one. So now see here this one. Here we know V value, U value, A value. Okay, we can calculate yes, right? So out of these two, you can use any formula. Out of these two, you can use either second one or third one, but we'll get the same answer. Okay. So now I will use the third one. I will use third equation of motion. Okay. M Hubli, you have answered 1 by 14. It's wrong. It's 1 by 15. And Sandhya Kulkarni, you have answered acceleration equal to 4 meter per second. Wrong. Okay. See, the SI unit of acceleration is meter per second square, and you got answer 4. It's wrong. Now see here, U is equals to U0. So now I will go with the third one. V square equal to U square plus 2AS. So first bring U square this side. Okay, that is V square minus U square equal to 2AS. Now bring 2A this side. So that is V square minus U square divided by 2A. Why it is divided by 2? Because here this is the form of multiplication. Then which is equal to yes. So then S equal to V square minus U square divided by 2A. Now substitute the values and type in answer first. Let's see who will give the answer first. Okay. So now here substitute the values and type in answer. Quick. Answer is 40. It's wrong. 40. Madan Idli, you got answer 40. It's wrong. Yes, sir. Nagaraj Mali Patel answered. The distance is 3 km. Yes, you are right. And who is this? Shwardra Hiremat. Yes, you correct. Your answer is right. 3 km. Okay. What about others? Yes, 3 kilometers. Sonia Gowda 3 km per second. Sonia Gowda, it's wrong. The ascent of distance or displacement is kilometer or meter. It's not kilometer per second. 3 kilometer. Yes, correct. Okay. See here. Now, first I will sum the values. So what is V value? That is 20. 20 square minus, right? That is 0 square divided by 2 into 1 by 15. 1 by 15. Okay. So now I will write here is 400 and 0 square is 0. 400 minus 0, that is 400. 400 divided by 2 into, see now 15. It goes to numerator, right? So we can write into 15. Okay. So 2 ones are 2, 200s are. Then S equal to 200 into 15. What is the answer? That is 3000 meter. Why? Because here now velocity, it is in meter per second, and acceleration is meter per second square. So finally you will get meter only. Okay, because the SI unit of distance or displacement is meter, kilometer or centimeter, but here we have kept these quantities in meter, right? We kept final velocity, initial velocity in meter, and acceleration also meter per second square. So that's why here we got answer in meter. So now convert this this meter into kilometer. You know, right? 1 kilometer is equals to 1000 meter. So we can write distance is equals to 3 kilometer. Okay. Here someone commented the video is not clear. So please change the resolution. Okay, change that from auto to keep your resolution 480. So if the video is not clear, please change your resolution. Yes. So next question. See here in your videos, go to settings, select this one 480p. Okay. See, don't select auto. Yes. So next, here right here. A car accelerates uniformly from 18 km per hour to 36 km per hour. 36 km per hour in 5 seconds. In 5 seconds. Calculate first one. Calculate first one. The acceleration Second one, the distance covered, by the car in that time. Okay. Yes. See. See, a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. So here the velocity changed from 18 km per hour to 36 km per hour. So clearly we can say that 18 km per hour is the initial velocity and 36 km per hour is the final. Okay. So u is equals to 18 km per hour. So convert into meter per second. How to convert? So it's very simple, right? So 18 into 5 by 18. So what is the answer? So tell me first. Next, final velocity v equal to 36 km per hour. That is 36 into 5 by 18. You know, while converting from kilometer per hour to meter per second, so we should multiply with 5 by 18. Already explained right in the previous class why we should multiply by 5 by 18. Okay, so tell me the answer. What is the initial velocity and final velocity? Yes, here Nagraj answered. Answer is 5 meter per second. What is that, initial or final velocity? Is that initial or final? Yes, that is u equal to 5. Correct, Madan Idli. So please put that SI unit. That is u equal to 5 meter per second. Okay. So initial velocity is 5 meter per second. Then final velocity is 10 meter per second. Okay. Yes. So I'll directly, okay. I'll write here. I'll write here 10. Sorry, 5 meter per second. 5 meter per second, and here 10 meter per second. V equal to this is so first we need acceleration, then we need distance. Yes, we need acceleration, right? So which formula? So we can't use second and third one because here we don't know s, right? So better we can go with third equation of first equation of motion, that is v equal to u plus at. Okay. So now substitute the values and tell me the answer. What is the acceleration? Quick. So here Sandhya Kulkarni answered acceleration equal to 1 meter per second square. Yes, you are right. Okay. Varun Kumar, 3 kilometer. See, that is the answer, not this one. Yes, acceleration A equal to 1 meter per second square. Others, only 2 students answered correctly. Acceleration, yes, Nagraj. Acceleration is 1 meter per second square. Yes, see here. We need a, right? We need a, first bring u and t this side. So that is the v minus u. Why it is minus? Because here it is plus, right? Next, a into t. So bring a this side. So v minus u divided by a is equal to t. Okay? Or we can write this as t. So t, sorry, a, right? We need a. So keep a here and t. So we can write this as a equal to v minus u divided by t. A is equals to, so here what is v? V is final velocity, that is 10, and initial velocity 5. 10 minus 5 divided by t, that is 5. So 5 by 5 equal to 1 meter per second square. Okay, so acceleration is equal to 1 meter per second square. Next, so here we got acceleration, right? That is 1 meter per second square. Then we need the distance covered by the car in that time. So its velocity changed from 80 to 36 in 5 seconds. So now how to calculate? Yes. So here we have two formulas, right? If you use the second one, yes, definitely. Now here we know the u and u, t and a will, right? Yes, we can use second one. So if you use the third one, we know u, v, u, a. Yes, definitely we can use even third equation of motion also. Okay, so but we'll get the same answer at the end. If you can use yes or me, but we'll get the second equation of motion or third equation of motion. So we'll get the same answer. So now I will use the second equation. So S is equals to ut plus half at square. Yes, already it is the formula is arranged, right? So S is one side, the remaining terms another side. So now substitute the values and tell me the answer. Substitute the values and tell me the answer first. So substitute what is u, what is t, and what is a. Tell me the answer. Quick. Let's see who will be the first. Yes, Nagraj Malpad answered 37.5. Correct. 37.5 meter. Yes, Shivana Rudriya Hiremat, correct. Then Sonia Gowda, yes, correct. 37.5 meter. No looking clear, sir. M Hubli. Just wait for it, okay? Then Shivakumar answer, yes, correct. 37.5 meter. Yes. Now see here. I'll substitute the values. So what is the value? That is 5. Whatever time 5 into 2. What is a value? That is 1 into t value 5. That is 5 square. Okay. So 5 into 5, 25. S is equals to 25 into 1 by 2. 5 and 5, 25. Okay. Yes. So now, sorry, this is plus, right? 2 ones are, that is 12.5. Okay, so S is equals to 25 plus 12.5. So you will get an answer. S is equals to 37.5 meter. Okay, so here everything is in meter per second, right? So yes, initial velocity, final meter, acceleration is also in meter, so that's why we got answer in meter. Hope you understood this one. So some students are we have sent the video is not looking, video is blur. Okay, so please change your resolution or maybe that internet is slow in your home or in your area. Yes. So now next one. Yes, Sonia Goda, you have answered. We want to ask about surface. Yes, ask now only. Please send your question. Yes, sure, Rudra, sir, understanding clearly, sir. Yes, very good, no problem. The brakes are applied to a car. The brakes are applied to a car. Produce and an acceleration of 6 meters per second in the opposite direction. Opposite direction. Opposite direction. To the motion. Okay. If the car takes 2 seconds to stop for the application of brake. Application of brakes. Calculate the distance it travels during this time. Calculate the distance it travels during this time. Okay. Yes. Here the brakes are applied to a car, produce an acceleration of 6 meters per second square. Here, so clearly we can say that the car is moving. Okay. See, we can apply brakes for moving car, right? So here the acceleration is 6 meter per second square in the opposite direction to the motion. Okay, see this one is very important. Opposite direction to the motion. Next, if the car takes 2 seconds after the application of brakes, calculate the distance it travels during this time. Yes, now tell me the answer first. Now question number. Okay. So Varun Kumar, you have answered 5 meter per second and 1 meter per second square. That answer is for previous question, I think. Okay. Yes. So now tell me the answer for this question. Here we need yes, right? So yes is present here and here. Okay. First write the data. What are the data given? So here acceleration given, right? So acceleration A is equals to what? So now tell me what is the acceleration? That is 6 meter per second square. Is it 6 meter per second square or minus 6 meter per second square? So here acceleration equal to minus 6 meter per second square. Why? Because see here in the opposite direction. So see, listen here. When the velocity increases, then we will get a positive acceleration. Here the velocity decreases, right? When you apply a brake, what will happen? Definitely we can say that speed or velocity decreases. So here we will get negative acceleration. Clear? Here they are told, right? The brakes are applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. Okay, and see here, if the car takes 2 seconds to stop after the application of brakes, so clearly we can say that that car, okay, so it comes from motion to rest, motion to rest. Clear? Because initially it is moving, finally it came to rest. Okay, so now we can say that final velocity is equal to 0. If the object initially at rest at the time, initial velocity is equal to 0. Okay, so now here acceleration equal to minus 6 meter per second square. Here you should know why. Okay, because here velocity decreased. If the decreases, then we will get negative acceleration. Then so final velocity equal to 0 meter per second. Why? Because finally that car it takes 2 seconds to stop. Okay. Next time, that is t equal to 2 seconds. Okay. Yes, calculate the distance. So now if I use the second one, here we don't know u, right? So we can't use second one. Okay. Next, suppose if I use third equation of motion, here also we don't know u, right? If I will use first equation of motion, v is equals to u plus at. Okay. U is equals to 0 plus 6 into. So we have got initial velocity, that is 12 meter. Second equation of motion. Okay. Is the third one. Here the distance is 12 meter. Okay.